Today I will explain about the lab 1 of digital signal processing. In digital signal processing laboratory, in first experiment, we will know some basic filters which use it to uh, filter the signal. The aim of our experiment is to write an Arduino program for studying the performance of moving average filter and first order derivative filter. The first one is moving average filter, and next derivative filter with first order difference, and third is derivative filter 3-point central difference. These three main filters we will study now, and later we will understand how to apply these three filters to different scenarios depending on the situation. First, let us understand what is moving average filter. Moving average filter performs three important functions. First one is it takes input points and computes the average of those points and produces a single output. Uh, One of the characteristics or parameter of the moving average filter is its length. Length in the sense, if I say moving average filter with length equal to L, means it will take L number of points and it will produce one output. It will take L number of points and it will produce one output. From the current situation, it will to the previous values, to the previous L values, it will take total L values and it will compute its average. This is the input output relation of moving average filter. Due to the computation and calculations involved, the filter introduces a definite amount of delay. Understood? Okay, the filter acts as a low pass filter. Low pass filter means it will smooth the signal, it will smooth the output, it will remove high frequency components. This is the input output relation of the moving average filter. If you observe this, this is the moving average filter with length equal to L. So it will take L input points, it will produce one output only. From the current position, it will include previous L minus 1 samples in with present input total L number of points. So it will compute its average and it will give to us. This is, if you for example, if you observe, this is the moving average filter with L equal to 5. So it output equation is 1 by 5 times x of n plus x of n minus 1 plus x of n minus 2 plus x of n minus 3 plus x of n minus 4. So if this is x of n, this is my current input, I am multiplying with it with 0.5. Next I will give one delay and I will take that x of n minus 1, this is previous input, and this is again one delay, this is x of n minus 1, x of n minus 2, again one delay, x of n minus 3, again delay, x of n minus 4. Here this is the summation operation here going on. Here the output will, this is the moving average output. When signal is changing rapidly, in that case signal contain high frequency component. Since we are taking the average of those points, average of some L number of points, and we are calculating a 1 point, we are giving 1 point as output, so we will get the smooth curve, means the moving average filter is removing high frequency component. Let us study the Arduino program of the moving average filter. As we know that the Arduino program consists of two loops, wide setup and wide loop. In wide setup, I am mentioning the baud rate like serial dot begin 96000. This is the baud rate. To plot the signal or to see the monitor. This is our input signal, float x of 1000. Like I am taking 1000 samples, x of 1000. These are the values input samples. So I am fixing the length of my moving average filter is 8. So int L equal to 8. So this is the output. Since we need uh, to compute the moving average filter, we require L points. So I am starting with L at I equal to L. Like if my moving average length is 8, so I will start with 8th location and I will take all previous 7 samples and I will compute the average. That's why I'm starting with I equal to L and I less than 1000 I plus plus. So I need to calculate sum. So I am fixing the I am initializing sum equal to 0. In this for loop I am calculating the sum of L points. Here L is 8. Here I am averaging it. So since I need to plot both input and output, I am adding one DC value to the output so that we can differentiate input and output signal. This is the Arduino program of moving average filter. This is the output. Here this red signal is the input signal. If you observe, it has some high frequency components. High frequency component in the sense it is where changing rapidly. It has many spikes. So this is the output of moving average filter. If you observe clearly, it is more smoother than the previous. It is a more smoother than the input. So it is removing high frequency component. Moving average filter will act as a low pass filter. It will smooth the curve. Next filter is derivative filter, first order. This is the input output relation, y of n equal to x of n minus x of n minus 1. This derivative filter preserves the edges. It is a high pass filter. Like when the signal is changing rapidly, at that those where the points where signal is changing rapidly, this derivative filter will preserve or capture those points. It is act as a high pass filter. This is the transfer function of derivative filter of first order. If you apply z transform to the both sides, you will get the this equation. You understood now? Derivative filter is a high frequency high pass filter. It will preserve the high frequency component. High frequency component means their slope is varying rapidly. Slope is more means it edges. It will preserve edges. If you observe this code, as I said earlier, this is our wide set of loop and this is our input signal. I am applying first order derivative filter to the smoothed signal. Smoothed signal is means first I will pass my input signal through moving average filter. After getting output, for that output I am applying first order derivative filter. So as we seen earlier, this is the code for the moving average. Here also L equal to 8. For that I am getting output is y. For that output I am calculating the difference. So here my final output is w. We will plot here the y and w. I am calculating just the difference with respect to the previous value. Mm, this is the graph. This is the smoothed signal output of the moving average filter. I gave this output to the first order derivative filter as an input. So this is the output of my derivative filter. If we observe here, from here to here the signal is almost constant. So from here to here signal is changing. Like since here from here to here there is a edge or high frequency or signal is changing rapidly. That's why here we are observing up and downs. So first order derivative filter captures the edges or preserve edges, because here signal is changing rapidly. That's why we are observing up and downs in the output. Next one is derivative filter. This is 3-point central difference. The input output relation of 3-point central difference will given by this equation, and this is the transfer function. Central difference filter, 3-point central difference filter also high pass filter. It will also preserve the edges or it will preserve the highly varying components. Right now we studied moving average filter, which is low pass filter, then derivative filter of first order. This is a high pass filter, and this is central difference filter. This is also high pass filter. Again This is wide setup, this is input signal. Here also I am applying central difference filter to the smoother signal in the sense to the output of the moving average filter. I am giving output of the moving average filter as a input to the central difference or 3-point central difference filter. So this is the this is the Arduino program. Here my output, this smooth signal is y, so for that y I am calculating central difference, y of I minus y of I minus 2. I am storing that in w, so I will plot here w and y and x, where x is the input signal, y is the output of the moving average filter, and this w is the output of the central difference filter. Mm. If you observe clearly, this is input signal, the green one is input signal, which is very noisy, and it contains some high frequency component, so I pass it through the low pass filter, that is moving average filter. So I got this smoothed version. This smoothed signal or this red signal I sent as an input to the central difference filter, so I got this output. If I observe clearly, it is also preserving the edges, means it will also passing the low frequency passing high frequency components. It is also high pass filter. uh, Before going to further, let me ask you a few questions. Hmm. Right, till now we studied moving average filter, derivative filter, a first order difference, and derivative filter 3-point central difference. Now with this knowledge or with this experience, we are in a position where we can choose which filter for which operation. Like I will put two questions forward you. The first question is, choose a filter to smooth out high frequency noises present in the signal. Like if you are a signal processing engineer, like if a layman or common man come to you and ask, he want a filter which smooth out high frequency noises, which filter you will suggest? And second question is, another that person also want another filter to emphasize high slope portions in the signal. According to your previous knowledge, which filter you will suggest him? First question is, he needs a filter to smooth out high frequency noises present in the signal, means he want low pass filter, he want to remove high frequency components. So with our previous knowledge we can suggest him, sir, you can use moving average filter to smooth out high frequency noises present in your signal. It is a low pass filter, so high frequency component will be removed. For the second question, we need to choose a filter to emphasize high slope portions, to capture high slope portions. With our previous knowledge we can say that sir, you can choose derivative filter to emphasize high slope portions, because it is a high frequency high pass filter. It will preserve edges which are nothing but high slope portions. In derivative filter of any kind, or first order difference or 3-point central difference, you can choose. Now further we will study, in next we will study how to extract the baseline drift component from the signal. This third question, we need to extract the baseline drift component. And the fourth question is, find out find output of a signal processing system which performs derivative filter, this first order difference, and then performs moving average filter with n equal to 8, n in the sense length. First we will study the third question. Okay, before going to extract the baseline drift component, first we need to know what is the baseline drift component. Let me explain it. uh, in biomedical signal processing or in any signal, when we are extracting signal by using devices, like for example I'm extracting ECG signal, my device will be in heart, or like my concentration will be in one particular organ, but due to the movement of any other organs or other muscles, or I can say from disturbances from the surroundings. Some value will be added to the our signal. Like for here we are taking PPG signal. When we are capturing PPG signal due to the other body movements or due to surroundings, okay, or due to some frequencies in the body, will add some noise to our signal, which that noise may not change the shape of the signal, but it will add some constant value or some baseline to our signal. That particular low frequency component or that particular DC or baseline component which is low frequency is called drift. To get exact PPG or exact ECG signal, you need to remove that baseline drift component from the received signal. Okay, I am again repeating, baseline drift component means it will added to the our signal during the extraction due to disturbances from the surroundings, disturbances from the other body movements or other muscles or other organs. It won't be change the shape of the signal, but it will add a baseline or it will add a DC component to our signal. So we need to remove that. How we can remove that? First, this is the input signal. I will pass this signal to the I will pass this signal through moving average with L equal to 8. So I got this signal. As I mentioned earlier, baseline drift component is a very low frequency component. Very low frequency, very low frequency component which added due to the disturbances. So if you want to get that low frequency components, means you need to attenuate the frequency, high frequencies as much as you can. So for that I will use moving average filter only, but I will change my order. To get the low frequency components, I need to increase my order or length of my moving average filter. So I will use the length of the moving average filter as a 400. Then I will get the baseline drift component. After getting the baseline drift component, I will remove that baseline drift component from the signal which I got after allowing it through moving average filter with length equal to 8. So first what I need to do, this is my input signal. I allow it I pass it through the moving average filter with length equal to 8. So I got Y. We I will pass I will pass uh, I will pass this Y to the moving average filter with length equal to 400, or I can pass our original input signal through the moving average filter with L equal to 400. So I am extracting baseline component, so I am using L equal to 400. I use our input signal, so I will get V is my baseline drift component. So to get exact PPZ as it is or exact signal as it is, I will remove the baseline drift component from Y. So I am doing here. So this is my code. So I am plotting input signal. I will plot the output of the moving average with L equal to 8. This is V is drift line component, and double is final original signal as it is. Okay, this is input signal. Blue one is, red one is moving average with L equal to 8. This is a baseline drift component. If you observe clearly, it is some constant DC. Like I took a particular interval of time. Okay, I took one portion of the PP signal. If you observe clearly here, the signal is not varying with respect to base. So here you can say base is constant. This may not be the case in other interval. Since I choose this interval, in this particular interval, the base of the signal is not varying much. So I got some kind of constant, some kind of DC. If my base is varying, this baseline drift component also will vary according to the base of the input signal. So now this Yellow or orange signal is exact signal, like original PPG signal after removing baseline from this red signal. Okay, by this way we will extract the baseline drift component. And finally, fourth question, find the output of the signal processing system which performs the derivative filter and then performs the moving average filter. First, this is our input signal. First you need to calculate the derivative difference. This is the difference signal. For the difference we will apply moving average filter. That's it. This by doing this also it will capture the high frequency components. This second one is differential filter will capture high frequency components. Since we after that we are smoothing that curve, that's it. We are not doing much it. If you observe code, this is our input signal. First I am doing differential operator, then I get W. For that W I am calculating moving average. These are the tasks we did. If you have any queries you can post in the comment section. Thank you very much.